Hi, in this particular video we're going to be looking at the specimen papers set 1, and the whole idea with this is that I'm going to break this whole paper down into about 3 or 4 videos, about 20-25 minutes long each, and then if you keep stopping and starting the video, have a go at each of the questions and then compare your solutions. If you want to download a copy of the paper, if you follow the link below in the description. Okay, so let's move on then to question number 1. So in question number 1 we're asked to change the subject of a formula, and at the moment we're saying that W, which is the subject, equals 3t plus 11. So if we want to make t the subject of the formula, what I'm going to do is I'm going to minus 11 from both sides. That means then that on the right hand side I get W minus 11, that equals 3t. And then I'm going to divide through by 3. So if I divide by 3, it means on the right hand side I get just t on its own, and on the left hand side I get W minus 11 divided by 3, and that's the answer to this particular question. Okay, let's move on then to question number 2, and in question number 2 we're asked to look at conversion and exchange rates. These type of questions are becoming kind of popular really with GCSE at the moment, and really all we're asked to do is, in this particular case, we've got some furniture prices. So if we look at the London price, well, the London price is as it is, which is £1,480. Okay, in Paris, we're given the cost of the furniture in euros, so 1,980 euros, and we're told the exchange rate is £1 equals 1.34 euros. So in other words, we've got to find out how many euros there are in 1,980 of them. So it would be 1980 divided by 1.34, and that's going to give me a price of this particular furniture in pounds of 1477.61. So it's actually marginally less expensive than it would be in the UK. All right, let's have a look at the New York price. So in New York we've got a dollar price of $2,250, and then once again we're given the exchange rate of £1 equals $1.52. So in other words, we want to find out how many of those there are in this price. So if we divide one by the other, it's going to be equal to 1480.26 in pounds. So they're all fairly similar. So if you wanted to find out the cheapest, then you've got Paris. So Paris is going to be the cheapest, and you're going to save yourself £3 by going off to Paris to get this type of furniture. Okay, so let's move on then to question number 3. I hope you're able to work through each of these by stopping and having a go at each of them. Please do so, and do compare your solutions with the solutions that I'm going to give. I'm just going to pull this out just a little bit so we've got a bit more space on there. Okay, so in this particular one we're being given a graph. Okay, now it's what they call a time series graph, and it gives some information about the number of pairs of shoes sold in a shop for the first 6 months, and what they're asking us to do is to effectively work out the mean. So at the moment they're saying the target is 96 pairs of shoes per month, and we've got to work out whether the shop meets its sales target. Okay, so what I'm going to do is I'm going to work out really how many pairs of shoes there are per month. So at the moment in January, if we look at the January scale, we've got January here, and that's going to be 110 pairs of shoes. Okay, so 110 in January, and basically I can do exactly the same exercise for all of the months. So in February, I've got that down as 84. You'd have to print this off and have a good look at it for yourself, but I reckon that would be 84. And then in March, okay, we've got 78. In April we've got 94. In May we've got 90, and in June I reckon that's going to be 120. So in June, 120 pairs of shoes. Okay, so pretty much that's the total amount of shoes that we've sold in those first 6 months, and if I add all of that up, that's going to equal 576 pairs. Okay, so if I then want to use that information to work out the average, I need to just divide that by 6. So if I do 576 divided by 6, that's going to give me the actual mean, which is 96. So 96 equals the mean. So in other words, the shop is actually on target. So yes, if I put yes on target. Okay, I hope that's all right for you. With mean and mean average, what you need to do really is just work out totals. Okay, and when you've worked out totals, you should then be able to work out the mean. Okay, hope that's all right for you. Let's move on then to question number 4. And question number 4, it gives you a chart, and then we're going to be talking about a frequency polygon, which actually are not particularly popular on GCSE, but occasionally you do get them. So in this particular one, we've got group frequency table gives information about the heights of 30 students. Write down the modal class interval. Okay, well, modal means most. Okay, so in other words, what's the group of heights where the greatest number of people are in that group? Well, it's actually this one, because there's 10 people that have a height between 160 and 170 centimetres. So the modal class is 160 to 170 centimetres. Okay, and then we're actually given a frequency polygon, and we're asked to write out 2 things which are wrong with this frequency polygon. Okay, well, there's an obvious one really, which is this bit here. So it's A to B. It's not an enclosed diagram, so you don't join A to B. Okay, and that's absolutely fine if you write something like that. Okay, and then the other one, which is less obvious, is that the frequency should be plotted as midpoint. Okay, so it's actually, if we look at this, they should be plotting 135 to 1 and 145 to 7 and 155 to 8 and so on. So actually the other thing that they've done wrong on this is that the frequency should be plotted, if I put should be plotted midpoints. Okay, and just as an example of that, I would write that down as 135 to 1. Okay, and this is height. Okay, or I could put in there 145 to 7, and this is also his height. Okay, and that makes it fairly clear. So in other words, they haven't plotted the correct coordinates. Okay, so let's move on then to question number 5. And question number 5, we're being asked to plot a journey. Okay, now these are perhaps a little bit more popular within GCSE, so this is something that you do definitely need to practice. Do come across these types of questions quite frequently. Okay, so speed, distance, time is a thing that you need to remember with all of this. So what we're saying is that this guy began a journey on a bicycle, and from 9 o'clock to 9:36 he cycled an average speed of 15 kilometers per hour. So that should be telling you that really we need to be looking at speed, distance, time. Okay, well, in order to work out speed, the formula that you need to remember is speed equals distance over time. Okay, now effectively they've given us the time. Admittedly, they've given us it minutes, but we need to change that. And they've also given us the speed. So we actually need to work out from that the distance. So in other words, we're going to plot this side of the graph. So between 9 and 9:36, he'll have gone a certain distance. Okay, so distance equals speed times time. Okay, so all I've done is I've just manipulated the formula to make it look a little bit easier and made distance the subject of the formula. Okay, so let's have a look at that then, filling in these blanks. So the speed is going to be 15 kilometers per hour, which is what they've told us, which is great. Now the distance, beg your pardon, the time is at the moment given to us in minutes, so we need to change that to hours because we're going to be giving this information in kilometers. Okay, so we need to have kilometers per hour. So at the moment we've got 36 minutes, so I'm going to write this rather than time as 36, I'm going to write it as 36 out of 60, because out of 60 means out of a whole hour. Now if you wanted to put that on a calculator, I think it works out as 0.6, something like that. But if you just leave it as it is, that's perfectly fine as well. And when you put that in a calculator as it is, you're going to get 9 kilometers. So in other words, in the first 36 minutes, so 36 minutes along to here, he's actually gone 9 kilometers. Okay, so we need to plot that to 9:36, which is here, and I'm going to plot that up to 9, which is about there. Okay, now I appreciate that on the video it's not so easy, but hopefully that'll give you a good idea, and when you print off and have a go at this question for yourself, you'll be able to track it through. Okay, so that's my first line. So from 9 o'clock in the morning he goes that distance. Okay, from there on in he then cycles a further 8 kilometers. So in other words, he's now cycled 9 plus 8, which is 17. So by the time we get to 10:45 he's cycled all of 17 kilometers. So that's going to be 15, 16, 17, so that's going to be up there. Okay, and there he is. Okay, so at this point here it's 9 plus 8, and at this point here it's 9. Okay, so that would give you some idea of how the actual travel graph should look for Bradley's journey. Okay, and then it says from 10:45 until 11 o'clock he cycled an average speed of 18 kilometers. Work out the distance Bradley cycled from that time to that time. So again, we've got a similar sort of thing. We're looking at distance is equal to speed times time. Okay, well the speed they've told us is 18, and the time is going to be 15 minutes, and that's 15 minutes out of 60 minutes, because 60 minutes and a whole hour. Now if you want to change that to a quarter or 0.25, that's absolutely fine, doesn't really make any difference. But 18 times 15 over 60 or 50 or a quarter or 0.25 should give you a distance then of 4.5 kilometers. So Bradley cycles 4.5 kilometers in the final quarter of an hour. Okay, hope that's all right. Please do have a look at the blog post, and if you have a look at that, you'll be able to download all of these prints. I do create these as a PDF, so you'll be able to compare your solutions, and hopefully my graph has been drawn okay. All right, so let's move on then to question number 6. I'm conscious of the time. At the moment we're on about 13-14 minutes, so I'm going to try and run this video to about 25 minutes, something like that. Okay, and on this particular one it says that Toby invested £7,500 for 2 years in a savings account, paid 4% per annum compound interest. So there is a formula that you tend to use with these sorts of things. If you're not sure about it, then please do have a look on the channel, and there are some videos. There's a playlist on using compound interest formulas. So that's going to be 1.04 squared. Okay, now the reason that's 1.04 is that's exactly the same as saying 104%, which is 104 over 100, and that's equal to 1.04. Okay, so do please check up on the playlist with that. If you put that into your calculator, you're going to get that equal to 8112. So at the end of the 2 years, Toby is going to have £8,122. Okay, let's have a look at the next one, which is question number 7. This particular one deals with Becky, and she's got some marbles. Okay, all right, so what we're basically saying is that you've got Becky, and you've got Chris and you've got David. Okay, well, we don't know how many marbles Becky has got, so we're actually going to say she's got X amount of marbles, okay? And then Chris has got 2 times as many as Becky. So he's got 2 times as many as Becky. He's got 2x of them, okay? And then Dan has 7 more marbles than Chris, okay? Well, Chris has got 2x, so Dan has got 2x plus 7. And what we're saying is when we add all of that up together, that's going to be equal to 57 marbles. Okay, so let's just do that. And what we're going to do is we're going to find out the value of x. So I've got x plus 2x plus 2x. Well, that's going to be 5x. If you like, I'll put a plus there, okay? And then I've got 7 here. So that's 5x plus 7, and that equals 57, okay? And then really it's just a case of solving it as you would any other linear equation. So I'm going to take 7 away from both sides. So if I minus 7 from this side, minus 7 from that side, I get 5x equals 50. And then I'm going to divide through by 5. And if I do that, it means that x equals 10. So in other words, Becky has 10 marbles, Chris has 20 marbles, and David has 27 marbles. So this is going to be x, which we've worked out as 10. So Becky has 10, Chris has 2x, which is 20, and David has 2x, which is 20, plus another 7. Okay, and then it asks you a bit of a strange question. It says, Dan says, if I give some marbles to Becky, each of us will have the same number of marbles. Dan says, if I give some marbles to Becky, each of us will have the same number of marbles. Okay, I don't know why Dan would say that, but he has done. Well, basically, Dan is incorrect. So he is incorrect because if he gave 7 marbles to Becky, if gave 7 marbles to Becky, then Becky would have 17, Chris would still have 20, and Dan would have 20. Would have 20. Okay, so actually, no, he's not going to be correct. They're not going to have the same number of marbles. Okay, bit of an oddball question right towards the end there, but I guess it's one of those things that is worthwhile kind of working through. All right, let's move on then to question number 8. This is a little bit of calculation for you, and you do need to know some formulas here, particularly the age-old one is the formula of a circle. You've got to know the formula of a circle, and that's actually pi r squared. Okay, so what they're asking us to do is to calculate the percentage of the area of the rectangle that's shaded. Okay, forget that. Let's just work out the area of the rectangle first. Okay, well, let's imagine that you've got a full rectangle. Okay, so the area of the whole rectangle, so if I put area of whole rectangle, and that's going to be equal to 19 or 16 times 19, which is going to be 304. Okay, so if it was a whole rectangle, it would be 304 centimeters squared. Okay, and then from that, I've got this semicircle that's being cut out. Okay, well, the first thing is I need to know the area of the circle, as I mentioned, but if I have the area of this semicircle, okay, well, that's going to be a half of area of a circle, which is pi r squared. Okay, so you need to know this formula. It does keep cropping up all the time. Okay, so I'm going to plug in some numbers. I've got a half and I've got pi. Now r on this, well, if you can have a look at the diagram, if you refer back to the diagram, what we've got is this, which is 16. So that basically means that the radius is going to be half of 16, which is 8. Okay, so hopefully you'll be able to see that. That's going to be 8 squared. Pop that into a calculator. I'm actually going to get on a calculator 32 pi. Now, if you want to, you can just multiply through by pi, but you don't really need to, just for the sake of this particular calculation. Okay, so what I'm going to do is I'm going to then just refer to my calculator in a second, but I've got the percentage which is not shaded. So that's the first thing I'm going to do. I appreciate I've got to work out the area of the rectangle that is shaded, but what I'm going to do is take that away from 100% just because it's easier for me to do this. So the percentage that's not shaded is going to be equal to 32 pi, which is the area of the semicircle, out of 304, which is the area of the rectangle itself. So if I just plug that into my calculator, what I end up with is, just bear with me a second, so 32 times shift pi divided by 304, that's going to be equal to 0.33 06939 and so on. Okay, that's fine. And then if I want to work out then the percentage which is shaded, which is the information that they're asking me for, then I'm just going to do 100, or if you like 1 minus this value, so minus the answer. Okay, so if I then work that out on my calculator, that's going to give me 0.6693, which is the same as saying 66.9%. Remember that these are actually decimal equivalents because the calculator works in decimals, so it's going to give me a decimal equivalent. Okay, so to 1 decimal place, that's going to be 66.9. Okay, hope that's all right for you. Please do print off the PDF and have a look at it for yourself. So what we're going to do then is move on to question number 9. And question number 9 deals with bearings, which is also one that seems to come up a fair bit. Okay, so it's worthwhile following some of the links on the playlist or on the website, and you can have a look at some of the bearings for yourself. Okay, so it says the bearing from B, the bearing of B from A is 70 degrees. So this is you're going to be very careful about this. So bearing of B from A. So what we're saying is that if we're on A, the bearing of B is actually 70 degrees, okay? And then it tells us that we've got this angle is 50 degrees, and we're also told that AB equals CB. So what we mean is that this distance AB is the same as this distance CB. So hopefully you can see from that what you've actually got is an isosceles triangle where this is 50 degrees and these two lengths are the same. Okay, what that means then is I can calculate this value here and this value here because these values are the same. So if I look at that, it's going to allow me to calculate these values at the bottom here of this triangle, and they're both going to be the same. And the way I'm going to do that is I know that a triangle adds up to 180 degrees as internal angles. So I've got 180, and I'm going to take away the 50 degrees here, which is at the very top, and that's going to give me 130 degrees, okay? So 130 degrees is these two angles added together, okay? So if I add those two angles together, or rather if I divide those two angles, if I divide 130 by 2, that's going to give me the value of each of these angles as 65 degrees. Okay, so therefore this is 65 degrees and this is 65 degrees. So if I want to then work out the bearing of C from A, it means that I'm on A and then C is just slightly behind me. It's not towards my right hand side, it's kind of behind me a little bit. So all I do is add these two numbers together. So I've got 70 degrees here plus 65, that's going to be C from A is going to be equal to 135 degrees. Okay, so to answer this particular question, the bearing is 135 degrees. Now I would say they do use isosceles triangles from time to time, so it is kind of worthwhile getting to grips with bearings, but I certainly would say do practice bearings because they do tend to come up quite a bit on a lot of these types of papers. Okay, so that's 25 minutes into this particular video, so I think what we'll do is we'll stop there. That's taking us to the end of question 9. We'll take a bit of a break. I hope it's been useful for you. If you're not sure about anything, please do add a comment below. I'll always come back to you. Subscribe to the channel, and I'll look forward to seeing you inside the next video.